All right. Problem 9 says a medical researcher measured the pulse rates in beats per minute of a sample of randomly selected adults and followed the following t-based confidence interval. With 95% confidence, we get this interval with mu in the middle. So explain carefully what the software output means. So what it means is we are 95% confident. The interval 70.9 to 74.5 beats per minute contains a true mean heart rate. Okay? That's basically what that means. Now, the interpretation in a minute of the interval itself is we're 95% confident that the mean pulse rate of all adults is between 70.9 and 74.5. Okay? So what's the margin of error? Okay? Well, remember when we're dealing with a t-interval, the confidence interval is x bar plus or minus t times standard error. And this is margin of error. Okay? So, how are we going to find this? Well, the first thing we're going to do is we're going to figure out what mu is. Well, where would mu be? Mu would be right in the middle of those two, right? So I'm going to say, okay, what's right in the middle of 70.9 and 74.5? And if I divide that by 2, so mu is 72.7. Okay, or x bar is 72.7. So what am I adding and subtracting to 72.7 to get this lower bound and this upper bound? So we can use either one of them. I'm going to use the 74.5. So the 74.5 minus 72.7, it's 1.8. So the margin of error is plus or minus 1.8. So if I do 72.7 minus 1.8, I get the lower bound of 70.9. If I do 72.7 plus 1.8, I get the upper bound of 74.5. So my x bar is 72.7 and my margin of error is plus or minus 1.8. Okay, beats per minute. So the researcher had calculated a 99% confidence interval. Would the margin of error be larger or smaller? Well, what would change? This would change. Everything else would stay the same. So let's just make one up. Okay, let's say we had a sample of 50 people. Okay, so our degrees of freedom would be 49. So a 95% confidence interval. Okay, remember 95% confidence interval. We're going to shade, I know it's not symmetric, but that's okay. We're going to shade the middle 95%. Okay, so this is 0.025 and this ends at 0.975. Okay, so if we did inverse t 0.975 with 49 degrees of freedom, then our t interval is like 2.01. Okay, now if we do a 99% confidence interval, okay, then that means that this is the 0.5% mark and this is the 99.5% mark. Because if this is 99%, I only have 1% left, and that means I have a 0.5% there and a 0.5% over there. Okay? So let's do the same thing, except we're going to change this to 0.995. And our t value is a lot larger, right? So it goes up to like 2.68. So if this value gets a lot larger, then I'm going to add or subtract a larger number. So that means that my interval would get larger. Okay, so the 70.9 would decrease and the 74.5 would increase because I'd be farther both directions from the mean. So I'd wind up with a wider interval. I'm more confident, but I'm less precise. Okay, so that's what you give up when you increase your confidence interval. So the margin of error would actually be larger.